This is section 9.1, and we're going to talk about polar coordinates. And this is different. This is in polar mode. The pole corresponds to the origin. So if you look at what you think of as an XY axis grid, instead of origin, we have the pole, and the polar axis is what you think of as the X axis. So when you're looking here, point P is represented by the coordinate pair R, which is this distance here, and then theta, which is the angle in here. So R comma theta. And R is the distance from the point to the pole. So R comma theta is how we look at polar coordinates. So if you were asked to plot 2 comma pi over 4, so in this grid, pi over 4 is 45 degrees, but you are at 2 from the origin or the pole, so your point is right there. That is 2 comma pi over 4. So in your homework, you may have some that look like this, and you're plotting the points and you're picking the right thing. So 3 comma 5 pi over 3. Well, 5 pi over 3 is over here in the fourth quadrant. You can look at your old unit circle and see that. So 5/3 is like 300 degrees, 5/3 pi. So all the way over here and then down 3. So that's how you would do that one. 2 negative pi over 4. Now a negative angle goes clockwise. Regular positive angles go counterclockwise. So that means we start here and we go to negative 45 degrees or negative pi over 4. And there's your 2. So that's that point. 3 comma 0. Well, 0 degrees, you're just still on this axis and you went 3. Negative 2 pi over 4. So this one's different than this. In this one, the angle was negative, so we were down here. This one, here's pi over 4. So we're that way, but we're at a negative 2r, so that means we go the opposite direction. So down here would be your point. Then we do have a process for converting from polar to rectangular. And you need to remember these two formulas here. X is r cosine theta, y is r sine theta. So let's go through an example. If you had 6 comma pi over 6, and that's in polar form, and you want to convert to rectangular. So first of all, you want to see what cosine of pi over 6, because you need that there. Cosine of pi over 6 is square root of 3 over 2. The sine of pi over 6 is 1/2. So we're going to take the r that we were given, 6 times this, which 6 divided by 2 is 3. So we have 3 square roots of 3 for our x value. 6 times 1/2 is 3. 3 is our y value. This is the rectangular form of this polar coordinate pair. And then if you're going the other direction, from rectangular to polar, so you want to know how to find r. R is the square root of x squared plus y squared. And then you need to know that tan theta is y over x. Okay, so we're trying to go from rectangular to polar, and you need an r value and you need a theta. So let's do this example. Convert 2 negative 2, so that's an x and a y, to polar. So first to find the r, we're going to do square root of 2 squared plus negative 2 squared. That's 4 plus 4. We get square root of 8, and you can simplify that by saying it's 2 square roots of 2. So that's our r, that is our r value. Now to find theta, we have to say tan theta is y over x. So tan theta is negative 2 over 2. That's negative 1. You want to find the angle that has a tan of negative 1. That is either negative pi over 4 or 7 pi over 4, depending on what the problem asks you for the form. But that's how you would do that. So you want to remember these things here for that formula. All right, let's go look at our problem set. So again, we start out with some language, complete the sentence below. The origin in rectangular coordinates, it coincides with the pole. So that would be, you choose that out of this drop-down menu. And the positive x-axis in rectangular coordinates coincides with the polar axis. If P is a point with coordinates r theta, the rectangular coordinates of x, y are given by x equals r cosine theta and y equals r sine theta. All right. Plot the point given in the polar coordinates, -8, 0, -8, 0. So -8, 0 is -8 this way. These are going by 2's. And so there's -8, and we didn't go anywhere on the angles, so that's that one. Let's look at number 4. Plot the point with the given coordinates. 2, 7 pi over 6. Well, 7 pi over 6, if you convert it to degrees, to think about it, it's equal to 210 degrees. You always want to multiply by 180 over 1. And so that cancels, you get 210. So 210 is in the third quadrant down here. So that's what that would be. -7, 3 pi over 4. And 3 pi over 4 is equal to 135. So 135 would be here, but our r value is negative. So it would be in, you'd find that angle, but then you'd go this direction for the point. 1, -5 pi over 3. Well, 5 pi over 3 is 300 degrees, but it's -300. So if you start here, you're going to go this way and end up back in the first quadrant and up 1. So it should be there. -3, -5 pi over 3. Again, -5 pi over 3. You're back here, but you are going negative on the r, so you go down 3 and you'll end up in the quadrant 3. All right. The polar coordinates are, and they gave you that, find rectangular. So cosine of pi over 2 is 0, sine of pi over 2 is 1, and 7 times 0 is 0, 7 times 1 is 7. So the rectangular coordinates would be 0, 7. Did I do? Okay. Polar coordinates are -7, 0. And so for this one, it's kind of the opposite. Cosine of 0 is 1, sine of 0 is 0. So you have -7 and you end up with 0. So that's the opposite of number 8. Polar coordinates are given here. Cosine of 3 pi over 4 is -√2 over 2. Sine of 3 pi over 4 is +√2 over 2. The r value is -3. And so you end up with +3 square roots of 2 over 2 and -3 square roots of 2 over 2. Number 11, you've got some decimals in there. And so cosine of 11 pi over 18 equals this. Sine of that equals that. So r value is 2.5 times the number you got here. Y is 2.5 times this value. And you have -0.86 and 2.35. And I think that will get us going on an introduction to polar coordinates.